Hello and welcome to Astronomy Daily, your daily dose of cosmic news and stellar discoveries. I'm Anna, and I'm excited to bring you the latest developments from across the universe. Today, we've got a busy episode exploring some fascinating stories from the world of space exploration and astronomy. We'll be diving into Virgin Galactic's progress with their new spaceplanes, which are reportedly on track for test flights next year. We'll also look at an incredible discovery made by the James Webb Space Telescope crystalline water ice found in another star system, offering new insights into planetary formation beyond our solar neighborhood. Then, we'll check in on NASA's Europa Clipper mission, which just tested its life-hunting technology during a Mars flyby, calibrating crucial instruments that will eventually search for signs of habitability on Jupiter's icy moon. Plus, we'll cover SpaceX's latest launch of Starlink satellites from California, marking over 1,000 satellites deployed this year alone, and we'll discuss the diplomatic milestone of Norway becoming the 55th nation to sign NASA's Artemis Accords for peaceful space exploration. So, strap in as we journey through today's astronomical headlines and expand our understanding of the cosmos. We haven't heard a lot from them in recent times, but Virgin Galactic is reporting significant progress on their new Delta-class spaceplanes, with production firmly on schedule to meet their ambitious timeline for commercial operations next year. During a recent earnings call, CEO Michael Colglazier highlighted the extensive technical developments across vehicle structures, propulsion systems, and avionics. The company has been transparent about their construction process, releasing video updates showcasing the current assembly state, and plans to launch a regular series of production updates beginning next month. This level of transparency signals confidence in their timeline, which remains unchanged from their previous announcements. According to that timeline, we can expect to see the first test flights of these new Delta-class vehicles, or spaceships as they're called, beginning in spring 2026. The company then plans a phased commercial rollout, with research payload flights commencing in summer, followed by private astronaut flights starting in fall. Perhaps most intriguing for would-be space tourists, Virgin Galactic anticipates reopening ticket sales in the first quarter of 2026. The company plans to bring on new customers gradually through what Colglazier described as a white glove onboarding experience. This measured approach will also enable Virgin to adjust pricing as needed. While specific ticket prices haven't been announced, we know they'll exceed the previous $600,000 price point. Beyond their standard operations, Virgin Galactic is exploring additional opportunities. The company is currently conducting a feasibility study for potential flights from southern Italy, focusing particularly on understanding the airspace requirements based on different flight paths and weather conditions. There's also increasing interest in alternative applications for their carrier aircraft. The plane's capabilities for high-altitude, long-endurance flights while carrying substantial payloads make it potentially valuable for other uses, including intelligence, surveillance, and reconnaissance missions. Colglazier noted, encouraging feedback from meetings with Defense Department officials and aerospace companies, mentioning multiple opportunities connected to the new Golden Dome Missile Defense Initiative. On the financial front, while Virgin reported minimal revenue and an adjusted EBITDA loss of $72 million for the first quarter, executives emphasized that peak spending on development is now behind them. CFO Doug Ahrens noted that as they complete the one-time investments in tooling and transition to assembly of the first two vehicles, the required spending by quarter goes down through year-end, suggesting a more sustainable financial path forward as they approach commercial operations. Next up, a truly stunning discovery. In a remarkable astronomical breakthrough, the James Webb Space Telescope has confirmed the presence of crystalline water ice in a dusty debris disk orbiting a sun-like star located 155 light-years from Earth. This discovery validates earlier hints detected by the now-retired Spitzer Space Telescope back in 2008, but with unprecedented spectral clarity that only Webb's advanced instruments could provide. What makes this finding particularly significant is that researchers didn't just detect ordinary water ice, but specifically crystalline water ice, the same form found in Saturn's rings and throughout our own solar system's Kuiper belt. This crystalline structure tells us about the temperature and formation conditions in this distant planetary system. The star at the center of this discovery, designated HD 181,327, is remarkably young, just 23 million years old compared to our 4.6 billion-year-old sun. Its debris disk is thought to closely resemble what our own Kuiper belt might have looked like billions of years ago, providing astronomers with something akin to a time machine for studying planetary formation. Webb's observations revealed fascinating details about this system's architecture. There's a significant dust-free gap between the star and its debris disk, where researchers believe frequent collisions between icy bodies continuously release tiny particles of dusty water ice, particles perfectly sized for Webb's instruments to detect. The distribution of ice throughout the system follows a pattern that makes perfect sense from a physics standpoint. The highest concentration, over 20%, exists in the cold outer regions of the debris disk, with much less in the middle areas, and almost none detected close to the star. This pattern likely results from ice vaporization by ultraviolet light in the inner regions, or perhaps because that ice is trapped inside unseen planetesimals. This discovery has profound implications for our understanding of planetary system formation. The presence of water ice is crucial for building giant planets, and until now, astronomers could only study this process in our own solar system. As Christine Chen from the Space Telescope Science Institute noted, we can finally examine how water ice functions across different planetary systems. What's particularly exciting is how the striking similarities between HD 181,327's debris disk and our own Kuiper belt suggest that our solar system's development may be more representative than unique. This discovery validates theoretical models about how water distributes through forming planetary systems. As astronomers continue mapping water ice across different star systems, we're building toward a more comprehensive understanding of planetary formation throughout the galaxy. This research also opens exciting possibilities for understanding how water essential for life as we know it gets distributed during a system's formation and potentially delivered to habitable zones where rocky planets reside. Future Webb observations of additional debris disks will likely reveal whether the patterns observed in HD 181,327 represent a universal principle of planetary systems. As we learn more about water distribution in the galaxy, we're ultimately gaining insight into the conditions that may have set the stage for Earth's own evolution and the emergence of life billions of years ago. Now let's turn our attention to NASA's Europa Clipper mission, which recently used a Mars flyby to test some of its most critical life-hunting technology. This spacecraft, currently en route to Jupiter's moon Europa, captured remarkable infrared images of the red planet during a gravity assist maneuver that served a dual purpose, helping the spacecraft reach Jupiter faster while also calibrating its sophisticated thermal imaging camera. On March 1st, Europa Clipper swooped just 550 miles above the Martian surface, using the planet's gravitational pull to reshape its trajectory. During this 18-minute window, the spacecraft's infrared camera, called the Europa Thermal Imaging System, or ETHEMIS, captured more than 1,000 grayscale pictures, 1 image per second, creating a comprehensive thermal map of Mars. The team later applied color to these images, with warm areas depicted in red and colder regions shown in blue, creating a striking visualization of Mars's temperature variations. This wasn't just for show. Comparing these new images with established Mars data allowed scientists to verify that ETHEMIS is working perfectly. As Phil Christensen from Arizona State University, the principal investigator for ETHEMIS, explained, "We wanted no surprises in these new images. The goal was to capture imagery of a planetary body we know extraordinarily well and make sure the dataset looks exactly the way it should." This calibration is absolutely crucial for the mission's ultimate goal. When Europa Clipper reaches Jupiter in 2030, it will begin a series of 49 flybys of Europa, an icy moon that scientists believe harbors a vast global ocean beneath its frozen crust. This subsurface ocean makes Europa one of the most promising places to search for life beyond Earth. ETHEMIS will play a vital role in this search by scanning Europa's surface for heat signatures. The moon's surface is marked by long ridges and deep fractures that many scientists believe are caused by ocean water, moving beneath the ice and breaking through the crust. By measuring temperature variations along these features, the spacecraft can identify areas where the ocean might come closest to the surface. If Europa is a really active place, those fractures will be warmer than the surrounding ice where the ocean comes close to the surface, Christensen noted. Or, if water erupted onto the surface hundreds to thousands of years ago, then those surfaces could still be relatively warm. The Mars flyby also provided an opportunity to test other crucial instruments. The spacecraft's radar systems were activated in unison for the first time, something that wasn't possible in Earth-based clean rooms due to the radar antenna's unusual length. Additionally, the team confirmed that the spacecraft's telecommunication equipment will be able to conduct gravity experiments at Europa by successfully transmitting signals to Earth while passing through Mars's gravity field. As Europa Clipper continues its 1.8 billion-mile journey to Jupiter, it will make one more gravity assist from Earth in 2026, before finally arriving at its destination in 2030. There, it will help scientists determine whether Europa, a moon orbiting a giant planet far from the Sun, could actually harbor the ingredients necessary for life to exist. In more satellite news, SpaceX has once again expanded its Starlink constellation with another successful launch from California. At 6:43 a.m. Pacific Time last Friday morning, a Falcon 9 rocket lifted off from Space Launch Complex 4 East at Vandenberg Space Force Base, carrying 26 more Starlink satellites into orbit. This launch marks a significant milestone for SpaceX, as they've now deployed more than 1,000 of their broadband internet satellites in 2025 alone. The pace of these deployments demonstrates SpaceX's commitment to rapidly expanding their global internet coverage. The mission, designated Starlink 15-5, was the 20th orbital launch from California this year. What's particularly interesting is that the launch proceeded despite a wildfire on the base north of the pad. The fire, which spread across 27 acres before being contained, fortunately did not impact launch operations. The Falcon 9 first-stage booster that powered this mission, designated B-1093, was making only its second flight. Its first mission was just 39 days earlier, also from Vandenberg, carrying another batch of Starlink satellites. This quick turnaround highlights SpaceX's increasing efficiency in refurbishing and redeploying their rockets. 8 minutes after liftoff, the booster made a precise landing on SpaceX's drone ship, aptly named Of Course I Still Love You, which was stationed in the Pacific Ocean. This successful touchdown marks the 130th landing on this particular vessel, and SpaceX's 448th booster landing overall, a remarkable achievement in rocket reusability. The company confirmed the successful deployment of all 26 optimized Starlink satellites about an hour after launch. These satellites will join the thousands already in orbit, providing high-speed internet access to users across the globe, including remote and underserved areas where traditional internet infrastructure is limited or non-existent. SpaceX continues to dominate the launch industry with its rapid cadence and reliable performance, regularly delivering both its own Starlink satellites and commercial payloads to orbit, while pushing the boundaries of reusable rocket technology. Finally today, the international community supporting NASA's vision for peaceful lunar exploration continues to grow, with Norway becoming the 55th nation to sign the Artemis Accords. The signing ceremony took place last Thursday at the Norwegian Space Agency in Oslo, where Norway's Minister of Trade and Industry, Cecilia Myrseth, formally committed her nation to this framework for peaceful space exploration. This milestone builds upon a space partnership between the United States and Norway that dates back over 6 decades. As acting NASA Administrator Janet Petro noted, the collaboration between these nations began in 1962 when NASA supported the first civilian suborbital rocket launch above the Arctic Circle from Andøya Space in Norway. The Artemis Accords represent much more than just signatures on paper. Established in October 2020 with the United States and 7 other founding nations, these accords outline principles and guidelines for how countries should approach exploration of the moon and deep space. They reinforce key concepts from the landmark 1967 Outer Space Treaty, emphasizing peaceful cooperation and transparent operations as humanity extends its reach beyond Earth. Norway's participation strengthens the international coalition behind NASA's Artemis program, which aims to return humans to the lunar surface and establish a sustainable presence there before eventually sending astronauts to Mars. The Artemis program itself has already made significant progress. Artemis 1 launched in November 2022, sending an uncrewed Orion spacecraft on a month-long journey around the moon. The next mission, Artemis 2 will carry 4 astronauts on a lunar flyby, though it has been delayed until at least February 2026 to address heat shield issues identified during the first mission. Artemis 3, targeted for 2027, is planned to be the historic mission that returns humans to the lunar surface for the first time since Apollo. However, the program faces uncertainty beyond this mission due to recent budget proposals. The White House's latest skinny budget proposes cutting NASA's funding by nearly 25%. These cuts would have profound implications for the Artemis program, potentially canceling the Space Launch System rocket after Artemis 3 and scrapping the Gateway lunar space station that was intended to support future missions. These budget concerns cast a shadow over the long-term viability of the program, just as international support continues to grow. The contrast between expanding global participation through the Artemis Accords and potential domestic funding challenges highlights the complex reality of modern space exploration, where scientific aspirations and political priorities must find alignment for missions to succeed. So, to sum up, as we reflect on today's space news, several fascinating threads weave together to form a tapestry of our current moment in space exploration. We're witnessing a remarkable convergence of commercial innovation, scientific discovery, and international cooperation that promises to reshape humanity's relationship with the cosmos. Virgin Galactic's progress on their Delta-class spaceplanes represents the continued evolution of commercial spaceflight, bringing us closer to an era where space tourism becomes increasingly accessible. Though still expensive, these advancements are gradually opening doors that were once firmly closed to all but a select few government astronauts. Meanwhile, the James Webb Space Telescope's discovery of crystalline water ice in a distant star system reminds us that we're not just exploring for exploration's sake. Each new finding offers insights into our own origins and place in the universe. The similarities between this distant debris disk and our own Kuiper belt suggest that our solar system's development may not be as unique as once thought, a humbling and profound realization. The Europa Clipper mission embodies humanity's enduring fascination with the possibility of life beyond Earth. By testing its instruments on Mars to prepare for studying Europa's icy surface, NASA demonstrates the methodical, patient approach needed to answer one of our most fundamental questions. Are we alone? SpaceX's relentless pace of Starlink launches illustrates how space is becoming increasingly integrated with our daily lives. With over 1,000 satellites launched this year alone, we're witnessing the rapid construction of infrastructure that's already transforming global communications. Norway's signing of the Artemis Accords reflects a growing international consensus around the principles that should govern our expansion into space. Yet, the contrast between this expanding global participation and potential NASA budget cuts highlights the complex political realities that often shape our cosmic ambitions. Together, these stories paint a picture of a species at a pivotal moment, developing the technologies to become truly multiplanetary, while simultaneously deepening our understanding of the cosmic neighborhood we already inhabit. The challenges are enormous, but so too is our collective ingenuity and determination to overcome them. Well, that brings us to the end of another episode of Astronomy Daily. I hope you've enjoyed our journey through the latest developments in space exploration and discovery. I'm Anna, and it's been my pleasure to share these cosmic updates with you today. If you've enjoyed the show, I'd love for you to join our growing community of space enthusiasts. Visit our website at astronomydaily.io, where you can listen to all our back episodes and dive deeper into the topics we've covered today. You can also subscribe to the podcast on Apple Podcasts, Spotify, YouTube, or wherever you get your podcasts to ensure you never miss an episode. For daily space content, follow us on social media. Just search for Astro Daily Pod on Facebook, X, YouTube, YouTube Music, Instagram, Tumblr, and TikTok. Thanks so much for listening today. The universe is vast and full of wonders, and I'm grateful we get to explore it together. Until next time, keep looking up.